Welcome back. Let's talk about position isomerism. Isomers, which differ from each other in the position of functionality, we call them position isomers. Now, there are three conditions to identify the position isomers, like we talked about in chain isomerism. That is, the first condition is isomers must belong to same class. That is, they must possess same functionality. The second condition is isomers must possess same main chain, or we can say mother chain. The third condition is isomers must differ only in the position of functional group. Keeping these three conditions into consideration, let's illustrate this with certain examples. We have these two molecules. First molecule is 1-chlorobutane and the second is 2-chlorobutane. Clearly, the chloro functionality is at position first in the first molecule, but it is at the position second in the second molecule. Both these molecules belong to same class, that is, they have same functionality, and both these molecules contain same mother chain, that is, of 4 carbon atoms, but they differ from each other only in the position of that chloro group. So these are the position isomers. In the next example, we have the following cyclic molecules. First molecule is 1,1-dichlorocyclobutane, second is 1,2-dichlorocyclobutane, and the third is 1,3-dichlorocyclobutane. Clearly, in all of these examples, the mother chain is same, that cyclobutane. All the three molecules contain same functionality, but all of them differ in the position of that chloro groups. Clearly, these are the position isomers. In the same way, we have these two. These are actually the dihalides. The first one is geminal dihalide and the second one is vicinal dihalide. So clearly the mother chain is same of 2 carbon atoms, possess same functionality, but again they differ from each other in the position of functional group. So these are also position isomers. Similarly, talking about the aromatic systems, these three molecules differ only in the position of functionality, as in the first the functional groups are 1,2, in the second it's 1,3, in the third it is a 1,4 isomer. So all these are position isomers. I hope you understand it. If you like my videos, please do not hesitate to subscribe my channel. Thank you.